Hey guys, welcome back. Hope you all are doing well. This is Mohammad Badruddin back again with the last lab from Prototype Pollution Vulnerability module. And in today's lab, we are gonna see how we can exfiltrate sensitive data via server-side prototype pollution vulnerability. This lab difficulty level is expert, and this is really good because whatever you learn up to now in prototype pollution vulnerability module, you are going to put everything here. So the content of this lab is saying this lab is built on Node.js and Express framework. It is vulnerable to server-side prototype pollution because it unsafely merges user controllable input into a server-side JavaScript object. Now, due to the configuration of the server, it is possible to pollute Object.prototype in such a way that you can inject arbitrary system commands that are subsequently executed on the server. Now, to solve the lab, we need to first of all find a prototype pollution source that you can use to add arbitrary property to the global object.prototype. Then we will identify the gadget to execute and inject the arbitrary system commands, and we will trigger at last a remote code execution of a command that leaks the content of Carlos home directory content to the public Burp Collaborator server. And then we will see the content of this file, and we will exfiltrate the content of this secret file, and at last we will submit the content of that secret file into the submit section to solve the lab. We have one test account with the username is Wiener and the password is Peter. Now the thing is, this lab I'm going to solve it with the Burp Professional because I didn't find out a workaround to solve this lab without Burp Collaborator. So let's go. I'm gonna access the lab here, and here we get all the content. Fine. So without wasting time, I'm just going to log in from the Wiener account. So the username is Wiener and the password is Peter. And once we log in, you can see this is the billing and delivery address, which we can update it or we can change it. So I'm just gonna submit it like it. And this is the post request which we are going to capture. And I'm gonna send this request to the repeater to analyze it further. And go to the repeater. This is our request. Let's just send it one more time. And as you can see, both request and response contain some JSON data. Okay, so first of all, the request is post request. So and it's submitting the data in the JSON format, and it's providing the data in JSON format. The second thing is, here you can see you are just submitting the data about the address with the session ID, but in response it contains the user information also, which is username, first name, last name, and then the address. One more thing which is important, it's saying is admin equal to true. That means in this lab you already have an elevated privilege, that is admin. So you are admin, and here you can see you already have the admin panel. So this lab could be more difficult if they do not give you privileges for the admin. So first of all, you have to escalate your privilege to the admin account by saying is admin equal to true, or by adding a property is admin equal to true, so that you can see the admin panel, and then you can access the admin panel functionality to exploit the specific scenario of this lab. Okay, so anyways, we already have the admin panel. Now if we run this run maintenance job, if we click it, you will see here the maintenance jobs are completed, and what these jobs are, the first thing is database cleanup, so it's completed successfully, and the second is file system cleanup, it's also completed successfully. So that means in this section some kind of child process is being called or executed in the background or under the hood, which is completing or which is performing these jobs. So these processes are on demand. Whenever you click that particular button, this process are being executed through the child process. Okay, because we are testing blindly, or this is kind of black box, we do not have access to the backend coding. So we can just imagine this by the response what we see here, or the functionality what this lab is providing to us. So database cleanup and file system cleanup, because in the lab they already said this lab is built up on Node.js and the Express framework. So Node.js and Express framework, so that means child process may be called here. Okay, now what I'm gonna do, I'm going to take this post request also and send it to the repeater. Now just send it one more time, and as you can see, everything is fine here. Success is true, success is true. The process name is data db cleanup, and this process name is file system cleanup, fs cleanup. Now back to the post request where we are updating our address, and here first of all we need to see whether this is vulnerable to prototype pollution or not. And for that purpose, what I'm gonna do, I'm gonna add here a property, and the property is going to be something like this. So here I'm gonna say underscore underscore proto underscore underscore, and here I'm gonna say, let's say, add something which is color, and the property, the value of this property is going to be red, blue, whatever you want. This is just for a test purpose, and I'm going to send the request. Now you can see the property is being added. Now if you want to see it more active or more practical, you can add here JSON space. So JSON space like this. Okay, and how many spaces you want to add? Let's say I want to add 5 spaces, and just send the request. You can see 5 spaces are being added, but you cannot see here spaces until you put it in the raw. So once I click on this raw button, not added. Why so? Because I made a mistake here. I must say JSON spaces. Okay, let's send this request one more time, and you can see this time 5 spaces are being added here. So let's try to polluting the prototype with some malicious property so that we can control and pass some child process exec-sync. Okay, so for that purpose, I'm going to say here shell, and let me just write, then I will try to explain it. I'm taking this payload from the PortSwigger solution itself. I like this because it is much simpler to understand, although there are different resources from where you can get the code with which you can exploit this server-side prototype pollution. Okay, but this one is simple, very, very simple. Okay, so here I'm gonna say input, and the input is going to be something like this, curl, and then URL, your URL. So although I'm going to solve this lab with the Burp Collaborator, in real life scenario, you will put here the attacker controlled server URL, which you control, which you publish. Fine. So let's see what, first of all, I'm going to do here is I want to show you something important. Okay, so here basically what I'm trying to do here is I'm trying to executing command through the Vim. So Vim is a editor, text editor, and in Vim you can also execute the command by typing here colon, exclamation sign, and then whatever command you want to execute, you can execute here. Let's say ls space hyphen la, and you can see the command is being executed. Press enter, and we can again type another command, let's say id, and you can see this is our id command. This is the result of id command. So the same thing we are trying to do here, but here we are trying to execute curl command. Okay, so what I'm gonna do, https:// and I am going to take the Burp Collaborator client, copy this, and I'm gonna paste it here. Okay, and I will also add /n for the new line. This is for the new line. So our payload will look like this. Okay, so just send this request. As you can see, this is being added. Now go back to the second request where we perform the maintenance job and send this request one more time. So what happened when this request is being sent in the backend, the process is being called which you injected, and you see this time success is failed and error message code is 1, and this is the message. Fine. And you can see here /dev/random, and then from the new line it executed vim. Okay, and it's saying some warning which is saying output is not to a terminal, vim warning, input is not from a terminal, same like that. Okay, so that means it's executing the command which we try to execute through vim. Now if we go back to our Burp Collaborator client, here you can see we found some DNS request because we put here a domain, okay, URL with a domain instead of IP address. So first of all, it will make a DNS query to resolve this domain name into IP address. So you find some DNS queries, then you find the HTTP request. So if I try to see the request, it is pretty normal, and this is the response. This is also normal. Try to see the next request. Okay, that means it is perfectly fine. So first of all, we tested whether we can interact with any out of band attacker controlled server or not, and it is perfectly fine. We can get the request and response to our attacker controlled server. Okay, we get the hits here. All these are the hits. Now it's time to execute the command. So in terms of executing the command, what I'm gonna say, so before curl, because what I want, whatever command we execute, we cannot see the result of that command in the response here in the second query. Okay, so you injected the command here, and once you execute this maintenance job, it is going to invoke your command, whatever you injected, but you will not see the result here. So it is kind of blind injection where you do not see the result of your executed command. So what we are planning to do is to execute the command and see the result somewhere else, and see the result to the attacker controlled server. So whatever command we execute, it will take the result of that executed command and send it to attacker controlled server. Fine. So here I'm going to say ls/home/Carlos. Okay, and then pipe it with the base 64, so that it will first of all execute this command ls/home/Carlos. It will see what directories and files are there, list of files and directories within the Carlos home directory. Then it will encode that result into base 64, and then it will execute the curl command. But what I want to do is I want to send that data, base 64 encoded data, with the curl command into this particular URL. So I'm gonna say like this. So -d, curl -d, this switch is used to specify the data. And also if I say @, so @ means before executing anything, it will read this data, okay, and then send it to this, okay, URL. Fine. So everything seems perfect. Let's just execute it, send the request. Request is sent successfully. Now go back to the other with the maintenance job. That means this one. So if I go to maintenance job, run the maintenance job. So on the same tab we are here. Now send this request again. This time it will also fail. Okay, now you can see it's failed. Now I'm going to back to the Burp Collaborator, and you can see these are the new requests. So first of all, it will perform the DNS query, send the DNS query to resolve the IP address of that particular domain name, and then it will interact with our HTTP server. So I'm going into the last request, go to the request, and you can see we find some base64 data encoded value. So I'm going to copy this and back to our decoder, and I'm going to paste it and smart decode or decode as base64. And you can see within the home directory of Carlos, we found two files, and we need to get the content or exfiltrate the content of this secret file. So the next step is to read this file, read the content from this file, and send it to our attacker controlled server or the Burp Collaborator client. Okay, so back to the repeater. Okay, go to the first lab, and here I'm gonna read the content of this file by using cat command, and the file name is secret. So this time it will read the file and encode the content of the file into the base64, then send that content as the data to this URL. Okay, so send the request. Fine, it's updated here. Go back to the second tab. This is for the maintenance admin job, and just send the request. It will again fail. Yeah, failed. Okay, now back to our Burp Collaborator client. Last time we get up to 11 requests, and up to now we do not find any new request. So we will wait for few seconds. Click on pool now, so it will refresh the session. Okay, now you can see we get another 4 requests. 2 are DNS and 2 for HTTP. So go to the last request, go to the request, and you can see this is the content of that file in base64 encoded value. So I'm gonna copy it back to our decoder, paste it here, and this is the content of the file. So I'm gonna copy it and paste it here in the submit solution. Okay, and that's it. We solved the lab. And if you like the content, please like, subscribe, and share. Bye.